Assalamualaikum and hi. In this video, let's look at inverse of a matrix. Okay, once again, to find inverse of a matrix must be from a square matrix. Okay, the inverse is denoted by A negative 1. Okay, and then next fact, if the determinant is 0, therefore the matrix A does not have any inverse. Okay, the product of A and its inverse is identity. Okay, so for inverse, this is always true, even though the sequence are different. That means before this, we have AB not necessarily equals to BA, but for inverse, A times A inverse will be the same as A inverse times A, which will result in the identity element. Identity is referring to this matrix 1 0 0 1, or for a 3 by 3, this will be 1 0 1 0 1 0. I'm sorry, this is 0. Okay, 0 0 1. Okay, these two are identity matrices. Okay, this is for 2 by 2 and this is for 3 by 3. For identity matrices, only there's only the value 1 on the main diagonal. Okay, for the other elements, they must be zeros. Okay, the same for 2 by 2. Okay, so this is identity. For inverse, you should denote by this notation. Okay, for a 2 by 2, it will be quite straightforward. It will simply be this formula, 1 over determinant, and then times the matrix, the modified matrix here. Okay, if you can see, between these two elements, we will change the place. Okay, so A22 will be here, and then A11 will be the last element, and then for the other diagonal, you will change the positive or negative sign. Okay, that means whatever the value here, this will be the negative of it. Whatever the value here will be the negative of it. Okay, let's do one example from exercise 12. Okay. Once again, we are doing for 2 by 2 matrix. Okay, so what is determinant of A? Determinant of A is for the main diagonal 10 minus, remember the operation is minus or subtraction, minus 12. So the determinant is negative 2. There's no problem if the determinant value is negative. Okay, this is not necessarily means it must be positive. It can be a negative value. Okay, so what is A inverse? A inverse is 1 over determinant of A times, okay, 5 will change to here. So 5 will become here and 2 will be at the bottom. So 2 is here, and then since we have 4 in the beginning, now it will become negative 4. Since we have 3 in the beginning. Now it will become negative 3. And then this is 1 over negative 2. 5, negative 4, negative 3, and 2. Or we can also rewrite this. This is negative 5 over 2. Negative 4 over negative 2 is 2. And then negative 3 over negative 2 is 3 over 2. And finally, 2 over negative 2, negative 1. Okay, now let's look at how to find the inverse of a 3 by 3 matrix. Okay, so the formula to find the inverse of a 3 by 3 matrix involve adjoint. Okay, and also the way you find determinant of a 3 by 3 matrix is also different from 2 by 2. Okay, I have explained on this one in previous video. 1 over the determinant of the 3 by 3 matrix times the adjoint of A. Okay, and also I hope you still remember that adjoint of A is the transpose of the cofactor, right? Find the inverse of A. Okay, hopefully it's exists. Okay, in order to check whether it exists or not, step 1, we must find the determinant. Find determinant. Okay. Once again, let's use the first row and let's write the positive and negative sign here. Positive, negative, positive. Okay, so what is determinant of A? It will be positive 1 times the determinant of 3, 5, 5, 12. Minus, okay, because we have minus here, minus 2. 1, 5, 1, 5. Okay, 1, 5, 1, 12. And finally, plus 3. Plus 3, 1, 3, 1, 5. And this is equals to 36 minus 25. 36 minus 25 is 11. Okay, and then minus 2 times, this is 12 minus 5, 7, plus 3 times 5 minus 2, minus 3, and that's 2. Okay, and this is 11 minus 14 plus 6. The determinant is 3. Okay, since it's not 0, then A inverse exists. Okay, but you must do more, because you need to find minor A, because from there you can get the cofactor A. Only then you can get the adjoint of A. Okay, I will provide the final answer for A inverse. Okay, I will provide the final answer for A inverse. Hang on for a while. Okay, the final answer of the inverse of A, you must get 11 over 3, negative 3, 1 over 3, negative 7 over 3, 3, negative 2 over 3, 2 over 3, negative 1, and 1 over 3. Okay, so I really hope that you will work on this question until you are done with A inverse. Okay, and then there's actually a way for you to check whether this is the correct answer or not. You can check that. You can try to multiply A with A inverse and check that are you able to get the identity matrix. If you are able to get the identity matrix, then your inverse is correct. Okay. I think I'll stop here. Thank you so much.